Alright guys, here's the review for your completing the square and complex number test. So we're going to first do two completing the square problems. One where there's a 1 in front of the x squared, so we don't need to create a 1 in front of the x squared. So we subtract the 4 over, we move that constant over, and now the big step of half the middle term, squaring it. What's half of 12? It's 6. And 6 squared is 36. We add 36 to both sides. When I factor x squared plus 12x plus 36, I get x plus 6 squared. You'll always get that binomial squared, and then negative 4 plus 36 is 32. We take the square root of both sides. The square root of x plus 6 squared is x plus 6. The square root of 32, it's always a plus minus when you take the square root of that right side, and it ends up simplifying to 4 root 2. If you can't simplify it, you just leave it. But if you can, you simplify it. And then we finish by subtracting 6 to the other side. Negative 6 plus or minus 4 root 2 is our answer. When we have a 2 or any number in front of the x squared, we divide each term by that number. So I divide all 4 terms here by 2, and I'm left with x squared plus 4x minus 7 equals 0. We now do the same thing we did on the previous problem. We add the 7 to the other side. Half of 4 is 2, and 2 squared is 4. So x squared plus 4x plus 4 equals 7 plus 4. We factor, and that becomes a binomial squared of x plus 2 squared equals the 7 plus 4 is 11. Square root of both sides, and we're left with x plus 2 equals plus or minus root 11. We can't simplify root 11, so we just leave it, and we get negative 2 plus or minus root 11. Alright, on our next page, now we're going to be dealing with complex numbers. So a complex number happens anytime there's a negative underneath the radical. We take the square root of that radical as if there was no negative there, and then we put an I. So the square root of negative 49 is just 7i, because the square root of 49 is 7, then we just put the I to account for that negative. The square root of negative 50, we break it down, 2 and 25, 5 and 5. It becomes 5 root 2, and I put my I there, so 5i root 2. 90 breaks down to 2 and 45, 3 and 15, 3 and 5, so the 3 goes on the outside. The two prime numbers get multiplied, become 10, go on the inside, and it's 3i root 10. When there's a negative in the radical and you can't simplify, you just pull the negative out, it becomes I root 7. Root negative 18, 2 and 9, 3 and 3, becomes 3i root 2. And then root negative 29 becomes I root 29. When we're getting the graphing and finding the absolute value of a complex number, the x-axis represents our real number, which is 4 in this case. The y-axis represents our imaginary number, which is 2i in this case. So to graph it, we go over 4 and then up 2. And then basically I'm creating a right triangle to get that distance from 0, 0, the absolute value. So we basically just square each number without the I. 4 squared plus 2 squared ends up being 20, and we take the square root of 20. The answer is 2 root 5. Negative 5 squared plus 3 squared is 25 plus 9, and my answer is root 34. And when I graph it, negative 5, I go left 5, up 3. And that's our negative 5 plus 3i. Negative 3 squared plus negative 6 squared, 9 plus 36 is 45. Square root of 45 is 3 root 5. And when I graph it, I'm going left 3, down 6. Adding and subtracting complex numbers is pretty straightforward. Combine the real numbers, combine the imaginary numbers. 4 and 3 is 7, negative 7i and 9i is 2i. Negative 7 minus 4 is negative 11. Negative 2i minus 6i is negative 8i. We have to distribute negatives. That's the only real challenge here. 7 minus 8 is negative 1. 5i minus a negative 7i, that's a double negative, becomes positive. So it's 5i plus 7i is 12i. And finally, 4 and 6 is 10. Negative 9i and negative 8i is negative 17i. When we multiply complex numbers, we're just foiling, and then we're dealing with an I squared, which is always equal to negative 1. Remember in the beginning of this unit, we said I equals the square root of negative 1. We said I squared equals negative 1. So 3 times 2 is 6. 3 times 6i is 18i. Negative 5i times 2 is negative 10i. Negative 5i times 6i is negative 30i squared. Negative 30 times negative 1, because that's what I squared equals, is a positive 30. So 30 and 6 is 36. 18i minus 10i is a positive 8i. We're just combining like terms. But the I squared has to be converted to a negative 1. So it's 36 plus 8i. Second one, 7 times 4 is 28. 7 times negative 8i is negative 56i. Negative 3i times 4 is negative 12i. And negative 3i times negative 8i is plus 24i squared. The double negative becomes positive. But 24 times I squared, that's a 24 times negative 1, becomes negative 24. 28 and negative 24 is 4. Negative 56i minus 12i is negative 68i. So 4 minus 68i. Finally, rationalizing the denominator. When there's an I in the denominator like this, we just multiply top and bottom by I. 3i over 2i squared makes the 2 a negative, and it becomes negative 3 over 2i. Remember, I squared always equals a negative 1. When you have an expression of a complex number down there where there's a real number and an imaginary number, we have to take the opposite sign. So I multiply the top and the bottom by 4 minus 5i. Notice I changed the sign in the middle. On top, we just distribute 20 minus 25i. On the bottom, we FOIL 16 minus 20i plus 20i minus 25i squared. When you FOIL these, the middle terms will always disappear, and the I squared is a negative 1. So negative 25 times negative 1 is 25. 25 and 16 is 41, so that's my denominator. And it's good form to split up the denominator. 20 over 41 minus 25 over 41i. When there's a 5 minus 2i, once again, we switch the sign. 5 plus 2i over 5 plus 2i. I distribute. On top, 30 plus 12i. On the bottom, 5 times 5 is 25. 5 times 2i is 10i. Negative 2i times 5 is negative 10i. And negative 2i times 2i is a negative 4i squared. The I squared is a negative 1, so it makes this a positive 4. 25 and 4 is 29. And then we split the denominator up. 30 over 29 plus 12 over 29i. And we end up with this answer right here. 30 over 29 plus 12 over 29i.